5.2, we're going to do factoring, your favorite thing ever. Again, for most of you, this is a major review, especially if you did it with me last year. If not, we're going to go through them all the time. I popped up here a few formulas that my advice for you is memorize them, learn how to use them, become very familiar with them. If you don't, there's way around it. There's ways to go around it. It's going to be a little bit harder and it's going to take you longer. But first, we're not going to worry about this. We're just going to remember that all product factoring. If we have x squared minus 12x minus 28, as soon as you hear factoring, this is what you're thinking of, especially when you factor a quadratic, okay? As we move on through this book, we're going to factor a lot more ways, but quadratics is just two sets of parentheses. I have an x and I have an x. And we did this last year a lot of times. We're thinking of, first of all, two numbers that have to times to negative 28. So you're going to have to think of numbers, first of all, that times to 28, which is 1 and 28, 2 and 14, 4 and 7. That's all your options. And now you know, because it's a negative 28, one of each of the sets has to be negative. So either 1 is negative or 28 is negative, or 2 is negative and 14, or 14 is negative, or for the third case, either 4 is negative or 7 is negative. Well, how do we look at it? Well, here's what we know. Not only that it times to negative 28, they have to add to negative 12. So I'm looking at this and I'm going, 1 and 28, no matter what I do to them, they will never add to negative 12. Even if this is negative 1, that becomes 27. If this is negative 28, it becomes negative 27. So that's out. 4 and 7 will never add to negative 12 either, because one of them has to be negative. If this is negative, this becomes a 3. If this is negative, this becomes a negative 3. I already know it's 2 and 14. And I always told you, the bigger number will have that negative sign because negative leads. So this becomes x minus 14, x plus 2. How do I know this? Negative 14 plus 2 gives me negative 12. So we're looking at two numbers. They times to negative 28. Right? 2 times negative 14, negative 28. They add to negative 12. 2 plus negative 14, negative 12. And we factored it. This is going to be over and over and over again. You look at the numbers that times to this, they add to this over and over. Now, what happens when we have a number in front of it, right? If we have this right there. I'm trying to come up with another example for that one just because I feel like we should. And I can't come up with one, but I think I can in a second. Here it is, x squared minus 8x plus 12. X squared minus 8x plus 12. Let's do one more example. Again, we think two parentheses. Two numbers, they have to times the positive 12. Okay, so it's either 1 and 12, 2 and 6, 3 and 4. But keep this in mind, they have to add to a negative. In order to times positive and add negative, I already know they're both negative. Okay, I already know I'm looking at two negative numbers. The only two numbers that add together to 8 are 2 and 6. Negative 2 plus negative 6 gives me negative 8. 2 and 6, right? There's tricks to look at this, and I told you whenever we did it last year, let's review this. If everything is plus, your signs will be plus. If your middle number is a minus, but your final number is a plus, both signs are negative. After this, everything, depending on what the signs are, one can be positive and negative. So that's how we factor like that. Let's look at this factoring over here. 3x squared. Let me erase it and write it bigger. I have 3x squared minus 17x plus 30. Okay, we're factoring this. Remember this? We did it last year. The book teaches you differently. I asked you to do it my way because this is a 10 here. I came up with a 30 from I don't know where. We always times this 3 to the back. And please remember you did that. This becomes x squared minus 17x plus 30. And now I know how to factor it, right? X and x. I'm looking at two numbers that have to times to a positive 30, add to a negative 17. They're both negative. I already know that. So numbers that times to 30 is 5 and 6. But when I add them, I don't get 17. 3 and 10. 3 and 10. When I add them, I don't get 17. What about 2 and 15? 2 and 15 gives me 17. Negative 2, negative 15, add up to negative 17. And you would say, I'm done. You're not done. Remember how we timed the 3 to the back? We need to divide it out. Please never forget this. This is the main thing. You got some of your stuff wrong last year if you did mess with me. Okay. And we said if you divide equally, in this case, 15 divided by 3 divided equally, it becomes x minus 3. 2 divided by 3, it doesn't divide normally, right? You have a remainder. That means this 3 comes in front of the x. It becomes 3x minus 2. So if you can divide and get a number out of it, it's not equal if you divide, whatever it's called, and get the number out of it, then you do the division. If that division gives you a decimal, then whatever is on the bottom comes in the front. Now remember, we talked about this, just a quick reminder for your homework. If this fraction can be reduced, we first reduce, then we bring number in the front, okay? We're going into the beautiful formulas over there. Let's look at this. 4x squared minus 25. This applies to this, okay? 4x squared is 2x all squared minus 25 is 5 all squared. Why is this nice? Because this formula solves it for you. You don't have to think of two numbers, not two numbers. This literally becomes 2x plus 5, 2x minus 5. And it's called the difference of squared. So if you can look at your numbers and realize, okay, this is 2x all squared, because 2 squared is 4, x squared is x squared, and this is 5 squared, then you just copy the numbers. One has a plus, one has a number minus, and you're good to go. Okay. Let's look at another problem that they give us here. 9y squared plus 24y plus 16. This is a hard one, unless you realize that this is 3y all squared, and this is 4 all squared. You want to look at the first, you want to look at the last, and see, is this a perfect square? Yes, it is, 3y. Is this a perfect square? Yes. The last step, I want to know what is 3 times 3y times 4. What do I get? 6, I get 24y. It matches. So this becomes 3y, that sign stays, plus 4 all squared. Okay. How would you do it differently? Here's the, we did this in class. I'm not going to do it again, but you would times the 9 in the back. Find the two numbers that times the number, divide and add to this number, then divide that 9 back out. And you can do it the old-fashioned way, but it's going to take you a lot longer. If you just take a look at this and you go, this is 3y all squared, and this is 4 all squared, and then you can check it, times them by 2, and it checks that number, and it's just a simple formula. Let's look at another one. 49r squared minus 14r plus 1. The first thing I want to check is the first and the last term. Well, 49i squared is 7r all squared. 1 is 1 all squared. The only thing I want to check is what is 2 times 1 times 2r, or 7r, so I get 14r, it checks, right? It's the same number. So this becomes 7r, I keep that sign, minus 1 all squared, and I solved all of that problem, okay? So if you manage to use these formulas, then it's a lot easier to identify which one is what, okay? If these don't work, then you have to factor the old-fashioned way. Now, there's other ways to factor that you hated last year. We're going to look at this. What if I have 5x squared minus 20? But this is not a perfect square. That is not a perfect square. But I can factor 5 out, right? 5 divides 5, and 5 divides 20. This becomes 5. 5 divided by 5, 1. So it's just x squared minus 20 divided by 5, 4. Don't stop. You're not done. Look at this. This is x all squared minus 2 all squared. This is that. Have you noticed how it's missing the middle term? So this becomes 5x plus 2x minus 2. So sometimes you're going to have to factor something out before you get to the right formula, which is x plus 2x minus 2. Look at another example. What if you have 2u squared plus 8u? 2u squared plus 8u. Just this is it. Well, If you remember, we did this before. You can write this 2 times u if you need to, plus 2 times 2 times 2 times u. Remember the whole 8, 2, 4, 2, 2? By now, I'm expecting you to do this quite fast. And we're looking, what do they have in common? They have a 2 in common. They have a u in common. What did I not cross out? A u plus a 4. The other way to look at it is, if you just can do it the fastest way. 2 divides 2 and 8, so a 2 comes out. U divides both of this, 1 comes out. And do it that way. But if this helps you do it this way, okay? Let's look at another factoring situation that we have in here. What if we have 6p squared plus 15p, I think it's a plus 9. And this is the last one I'm going to work. There's one more in the book, but you can look at that in the book, okay? Not a perfect square, not a perfect square. So you're going, well, what am I going to do? But look at this, 6, 15, 9. They all can be divided by 3, correct? I can put a 3 out. 6 divided by 3, 2p squared, plus 15 divided by 3, 5p, plus 9 divided by 3, 3, equals 0. Not a perfect square. This is just the old-fashioned factoring. This becomes 3 parentheses p squared plus 5p plus 6, or it doesn't equal 0 now, it's 3, 2 parentheses, pp. This is all plus, so I already know it's a plus and a plus. 2 numbers, 8 times, 2 6, to add to 5, 2 and 3. And we're done. Okay? There's one more example in there. You can look at it and figure it out from there. Now, when you hear solve, we went through this a lot of times, and we said when you hear solve something, that means you're going to equal it to 0. So if I would tell you solve this, that means it would be equals 0. You would factor it, you would start it like this, right? It should equal 0. It should equal 0. It should equal 0 until we get to this point. Once we got this point, this is easy. Either p plus 2 equals 0, which means p equals negative 2, or p plus 3 equals 0, which means p equals negative 3. So when you solve, you have to have a value for p, or for x, for y. Now, watch for your homework, because you're going to be tempted to do extra work. Okay. Some of them are going to start your homework with saying factoring, which means you end right here. Some of them are going to say solve, which means you have to go one extra step and give me the values. You can solve them all if you want to, but that's extra work for you, okay? So I would say pay attention to what they ask of you and go from there. I'm going to solve one of the examples in the book. They all work in the exact same way, so I'm not going to worry about it. Here we go. Let's just do the harder one. 2r squared minus 17. Oh, it's a t. We're going to make it an x. Minus 17x plus 45 equals 3x, sorry, minus 5. And I need you to remember that this, the way it works is, in order to solve, you need to equal it to 0, which means the 3 moves over, minus 3x, right? Then 5 moves over, plus 5. We do the opposite signs, right? So this becomes 2x squared minus 20x plus 50 equals 0, right? Remember how we said we can pull a 2 out? We can factor a 2 out? Because none of it is a perfect square. What if I divide the 2 out? I end up with x squared minus 10x plus 25 equals 0. And this is where your work can be easy or can be hard, okay? I can either look at this and go, well, this is the perfect square of x, and this is the perfect square of 5. 2 times 5 times x gives me 10x. This is x minus 5 all squared equals 0. It's the fast way. It's applying this formula right here. Now, you can also, don't worry about it, and go x, that's a minus, that's a plus. So I know they're both negative. I'm looking at 2 numbers at times 2, 25, and net to 10. 5 times 5, 25. 5 plus 5, 10. Negative 5 and negative 5 will give me a positive 25 and a negative 10 equals 0, which means x equals 5 or x equals 5. I will take either one of the solutions. The fastest way is just to see that it's x squared, because this can be put together as 2x minus 5 all squared equals 0. Why? This times by itself, right? Or you can just solve it like this. I don't mind either way. Now, as we move on, and I'm going to let you look through the other example in there, you have a word problem that says use the quadratic equation as a model, and it talks about a rectangular stained glass window that is 2 by 4, and you have 7 feet of clear glass to create a border of uniform around the window. What should the width of the border be? First of all, you need to know how you find the area of that thing. You know it's a 2 by 4, right? But you also know you have a border that's uniform, and we don't know the length of it. So the top and the bottom, if I do it like this, and you can look in the book and see it. If I put a border around it, I don't know how much is from here to here. I know it's X. I don't know what it is. This is also X, because this is all uniform, right? Right? So if I think of this area, it's going to be, the big thing is going to be 2 plus 2x, this is my width, times 4 plus 2x, this is my length. Area of a rectangle, if you remember, is length times width, right? So I need to know, first of all, what is the big area, right? This is my big area. If I open all of my parentheses, I end up with 8. This is a FOIL plus 4x plus 8x plus 4x squared, or 4x squared plus 12x plus 8. Now, I need to know what is just the area of the border. That's what we find out. So that means we're going to take the big area and we're going to minus the actual stained glass. So all of this is going to be minus the area of the stained glass, which is a lot easier, right? It's 2 by 4, so that's 2 times 4 would be 8, correct? Here the window is, yes, so it's minus 8. Did I do this? Not right. Because they got a number, yes, minus 8. So this becomes 4x squared plus 12x. This goes away. But here's what I do know. I know that the whole glass that comes on top of it, it's 7. They tell me at the beginning, it says you have 7 square feet of clear glass, right? So this needs to equal 7. I can move my 7 on the other side and end up with 4x squared plus 12x minus 7 equals 0, right? Because I'm going minus 7, and I just flip the 0 on the other side. I get to factor. Don't we love this? X squared plus 12x minus 28 equals 0. Why did I do that? I times my 4 in the back. Here we go. X, it's a plus and a minus. The two signs are flipped. I'm looking at two numbers that times to negative 28, but they add to positive 12. If you think of 2 and 14, if the 14 is positive and the 2 is negative, you times them, you get a negative 28. You add them and you get a positive 12. Plus 14 minus 2, right? Don't forget you have to divide that 4 out because we just timed it in the back. And remember how I told you these fractions have to be reduced before you bring it in? 2/4 is 1 over 2. 14 over 4 is 7 over 2. None of these divide equally, right? They don't. So the 2 comes in front. This becomes 2x plus 7. And then 2x minus 1 needs to equal 0. Which means we have two options. Either 2x plus 7 equals 0, which means 2x equals negative 7, x equals negative 7 over 2, or 2x minus 1 equals 0, which means x equals 1/2. Now, think about it. This is a real life problem. Can we ever have a border of negative 7 over 2 or negative 3.5? No, we can't work negative numbers. So my only option is my border has to be 1/2 of an inch, right? Is this feet or inches? I don't remember. Oh, 1/2 of a foot or 6 inches because we're doing it. So you always, when you do real world problems, are going to take out the negative solution, because in real life we can't do negative something. Now, before we're done, we have a graphing problem, and we're going to work it together. We're going to find zeros of a quadratic function, which basically is the same thing. You have to equal it to 0 and solve it. You have find the zeros, y equals x squared minus x minus 6. Okay, when they say find the zeros, there's two ways to do it. One is to factor. This becomes x minus 3, x plus 2, y equals that. How do I know this? I'm looking for two numbers that have to times negative 6, that have to add up to negative 1. Negative 3 times 2, negative 6, negative 3 plus 2, negative 1. Now that we're here, I need to find the zeros. So that means either x minus 3 is 0, or x equals 3, or x plus 2 is 0, x equals negative 2. Now, the book shows you a graphing thing, and we'll do it together here. This video is trying to be longer and longer. I don't know that I'm a fan of that, but it's okay. I'm going to go to y equals, I'm going to put this x squared minus x minus 6. And I'm going to do zoom 6. Remember, we messed with the window. Zoom 6. Here it is. If you're going to play with your little arrow and go back and forth, you're going to notice that you have your first intercept at x equals 3 right there. Your second intercept is at x negative 2 right there. And that's how you solve this, okay? Now, the last thing we're going to do is the quadratic model. An example 8. This is a long lesson. Hopefully we cover all this in class. I don't see how we will, but we'll do our best. It talks about revenue. So basically the revenue is going to be number of subscribers times the revenue is number of subscribers times the subscriber price, right? If we look at the word problem that you get there, if you go here and you read all of it, it says subscription price is $16 per year, and you get 30,000 subscribers. For each dollar increase in price, you expect to lose 1,000 subscribers. How much should you charge to maximize your annual revenue? What is your maximum revenue? Well, first of all, you start with 30,000 subscribers, right? So R is 30,000 minus 1,000x. Why? Because every time you increase your subscription by $1, you're losing 1,000 subscribers, right? You just don't know how much is their price. But the price of the subscription, you start at 16 and you add that increase, right? As much as you increase. And we get to do this wonderful thing. When you open all of your parentheses, you end up with, did they do all of the math in here? No, they just factor something out to find well, you can do that. You can pull the 10,000 out in here, or 1,000 out in here, and you end up with 30 minus x, 16 plus x, right? This is the two parentheses that you get. I can take that minus out to change the sign in here. Negative 1,000 x minus 30 x minus 16. Oh, no, x plus 16, sorry. And I know my two intercepts now. My x is 30 and my x is negative 16. These are my two intercepts, right? They say also the value x that maximizes is your average. That's where your axis of symmetry is going to be. So if I go 30 plus 16 plus negative 16 divided by 2, I get 14 divided by 2. My axis of symmetry is x equals 7. I know that part, right? And if I need to find how much is that, I'm going to come right back here and go, well, negative 1,000, 7 minus 30, 7 plus 16. I would absolutely tell you do this by plugging all of this into your calculator, and you're going to end up with an amount of 529,000. That's your maximum profit. That is your vertex. Okay, you plug it in, you get your vertex. So this is your 5.2. A lot of information, a lot of homework. I know that, but we'll do great. Happy homework.